And I thank the organizers for inviting me, and I think it's really interesting that now this is something novel that in this meeting of neuroimmunology we have 4 talks about Alzheimer's disease. I think this is very significant. I congratulate Dmitry and the committee for having this. I'm going to talk to you back. I want to take you back to the basics. What is the important, and what are the important things, and to question several things that we should discuss when we talk about Alzheimer's disease and neuroinflammation. The first thing is that we should understand what do we mean when we speak about Alzheimer's disease, because listening to some of the lectures here of the basic scientists, I'm not sure that we all speak the same language, that the clinicians are the same thing. And so what is Alzheimer's disease? So firstly, I can tell you that it's not what it used to be. It's different. When Esther, you are looking at me, when we went to medical school, did we know about Alzheimer's disease? Not as we know about it now. It was a different story. When Alois Alzheimer described the disease, this is not long before we went to medical school, he mentioned this as a unique disease. So when I went to medical school, I knew this was like almost 60 years ago, and I knew exactly that I'm going to become a neurologist, so I bought the best textbook of neurology that existed. This was Diseases of the Nervous System, written by Lord Brain, so you think about the Lord, talking about the brain, everything must be true, so I learned it by heart. And of course, it included also a section on Alzheimer's disease. A very small one about this rare disorder of early onset disease that occurs infrequently. And look what happened. Now it changed into an epidemic. So we use the same word that was used now by Alzheimer and by our teachers to call something, and we took the same name and use it for something else, for the elderly. Not that Alzheimer did not know about the elderly. He knew about them, but he said this is something different, and we have to take this to understand what it is. So what do we mean in the modern era of Alzheimer's disease? We say, here's the definition, or one of the definitions that I think most clinicians will agree upon: clinico-pathological entity of progressive dementia with specific neuropathological changes. Chava, you agree? Not quite? This is the definition. But it's a complex problem, and I want you to pay attention that this definition is unusual. It's unusual because I cannot think of any other disease which requires both the clinical phenotype and the pathological phenotype to define it. This is not like anything else that I can think of. Why is it that we require both the clinical phenotype and the pathological phenotype to define it? Because none of them are sufficient. So here is a study that was published recently about in North America, in the United States, from data coming from the best centers where patients who were treated by them and diagnosed as having Alzheimer's disease, when they came to autopsy, the pathologists say, you are right 70% of the time. 30% of those people were diagnosed in the best centers, using the best ways, as having Alzheimer's disease, actually had something else. And the other way also, many people who are diagnosed as having amyloid deposits in the brain have actually, so pathologically they have Alzheimer's disease. But clinically, again, 30% of them do not have dementia. So that's why it is so critical to have both the clinical phenotype and the pathological phenotype to define a disease. So this is highly unusual. And So we should think about the definition. I don't have time to go into details here. But in order to explain what I have in mind, I will ask you whether Alzheimer's disease is a disease in the first place. So why do I ask this question? What does it mean when I ask whether Alzheimer's disease is a disease? What is a disease? Actually, there are no diseases except in our mind. There are sick people. And we define a syndrome or a disease or something. But disease is an abstract concept. And if we want to call something a disease, we have to understand what is the underlying process leading to it, not just the clinical or the pathological phenotype. And in order to demonstrate this point, I will ask you about, again, I will go to my fellows. So, Oded, do you think that hepatic cirrhosis is a disease? Oded? Is hepatic cirrhosis a disease? No, of course not. Why is it not a disease? Because there are many different causes that can lead to hepatic cirrhosis. All of them have the same clinical phenotype, the same pathological phenotype, and the same biomarkers. So having the same pathology in a person who has the same clinical feature and the same biomarkers, bilirubin or transaminase or whatever, do not define a disease. Even the pathology is a syndrome, it's not a disease. So this is very important. So, but unlike hepatic cirrhosis, in which a good clinician can identify the cause, should be able to identify the cause of a disease in a given person, this is not the same in Alzheimer's disease. Because Alzheimer's disease is not caused by a single cause. Never. Alzheimer's disease is actually the end result of a neurodegenerative process, resulting from cumulative contributions by many genetic contributions, by many environmental factors, mainly vascular factors. So we all speak, and we heard here about amyloid, and of course amyloid defines Alzheimer's disease, rightly or wrongly, not the time to discuss. But the fact that it defines a disease, it defines it, so it's ID is associated with amyloid by definition. But to say that it is caused by amyloid, this is a theory, this is speculation. Maybe it's true, maybe it's not. Actually, I do not contribute to this. I think there is enough data to show that amyloid deposit is the end result, is a deposition. It's something that is coming at the end. And for me, amyloid as well as neurofibrillary tangles are downstream disease markers. These are like the tombstones in a cemetery. And if we go to the cemetery and look at the tombstones, we can understand many things that were going on. But nobody will assume that if we remove the tombstones, anybody will come back to life. And amyloid and neurofibrillary tangles are like the tombstones. What in human disease, if we want to look at the causes of an epidemic like Alzheimer's disease, we have to refer to the epidemiologist. And what do the epidemiologists tell us? They tell us, well, there are lifestyle factors in dementia. And smoking, excessive alcohol consumption, overweight, poor physical fitness, and as I mentioned before, also the vascular risk factors, which I call the hyper risk factors. Hypertension, hyperlipidemia, hyperglycemia, diabetes, hypernicotinemia, smoking, and inflammation. I will come back to inflammation in a minute. But this is what the cardiologists and internal medicine people talk about, the deadly quintet of the metabolic or dysmetabolic syndrome: insulin resistance, hypertension, diabetes, obesity, and dyslipidemia. And all these factors, all of them, are associated with inflammation. If you look at CRP markers, CRP or other markers of inflammation, they're all of these are associated with inflammation. We should think about it, that all these factors that are so important in the causation of what we call Alzheimer's disease are associated with inflammation. And this ties down with other data that we have learned over the years, again, mainly from epidemiologists. So firstly, the first observation is that anti-inflammatory drugs may decrease the incidence of Alzheimer's disease. So people who take anti-inflammatory drugs, maybe for rheumatoid arthritis or anything else, have a reduced frequency of Alzheimer's disease. And then very interesting study coming from Hawaii, long-term follow-up of people who, in their ongoing study on cardiovascular disease, they also found out after many years that many of the people who, Japanese people in Hawaii, who turned out to become demented, actually they found that they had some stored serum samples from them, and when they looked at these serum samples, they found that those samples that were taken 30 years before had a higher level of CRP in those who developed Alzheimer's disease as compared to the others. So again, the idea is that inflammation early on may be related, associated with what turns out to be Alzheimer's disease. And of course, in pathology, we know that the amyloid plaques are there, but it's not just the amyloid plaques that are characteristics. The amyloid plaques are associated also with a lot of changes that are inflammatory in regions. So the AD brain are characterized by enhanced pro-inflammatory environment created by activating microglia and astroglia around the amyloid, but not just there. And if we then go on and ask ourselves also what happens in other studies, again epidemiological studies like GWAS study, genome-wide association studies, you see what are the markers. And the markers, the tall tower here is ApoE4, of course, and the smaller ones are not related, none of them are related to amyloid genes, but they are all associated with other things, lipid transporting genes and inflammatory genes. So inflammatory genes are associated with the occurrence of Alzheimer's disease. So, as I mentioned, it's not by chance that there are activated microglia and activated astrocytes against amyloid plaques. I mean, if there is damage to the brain, like any other tissue in the body, there should be a reaction. The reaction is inflammatory. After all, during evolution, inflammation came about as something which is protective. So what do the activated microglia do there? Are they the bad guys, to use what the terms that Dana just mentioned? Are they bad guys? Or are these also the good guys? I mean, thinking logically, if they developed over so many years, if we have inflammation going on in any injured tissue all over the body, including in the brain, it should be compensatory, at least to a degree. So it may be that inflammation is double-edged sword. And in some way it can be beneficial, and in others it can be detrimental. So, and one point, for example, is that AD brain being characterized by astroglia, the astroglia atrophy there. And astrocytes are important, are very important in the maintenance of the brain, and particularly prevent deletion. So what is the concept? So can treatment with non-steroidal anti-inflammatory drugs protect from dementia? And these studies have been done, and many of them have been published, and they don't have a strong effect, as already has been mentioned, but some effect they do have. And meta-analysis shows that yes, taking non-steroidal anti-inflammatory drugs is protective, at least if you take it a long time before the onset of the dementia. Once you're demented, that's too late. That's like telling a person who has lung cancer, stop smoking. And if we go back to ApoE, we don't understand why ApoE4 is detrimental for Alzheimer's disease, which is a very important part of the story. But ApoE is also responsible for inflammation. So maybe this is an important issue. So the question, I think the critical question is inflammation really bad? And just before I finish, I want to tell you that I think that the studies that we have heard about in the experimental animals, experimental mice, transgenic, triple transgenic, 5 transgenics, are artifacts because they are not similar to what we see in Alzheimer's disease. They are not it's a similar pathological phenotype. It's not the same clinical phenotype. And definitely, it is not the same in the pathology. They have the gene that was taken from humans who have prosenylin mutations or APP mutations. And so these are models of the human early onset familial disease, not of the prevalent late onset sporadic Alzheimer's disease. So the question, I think the critical question that we should ask, that people who are doing these studies should ask, is the inflammatory really bad? Or is it more complex? Do we speak just about inflammation, yes or no? And I think Michal contributed to this in important ways. And I think we should try to understand whether controlling inflammation can help and whether we can only think about pro-inflammatory or anti-inflammatory, or whether we should think about modulating, harnessing the inflammatory process, some arms of which may be beneficial and others may be detrimental, boost or downregulate, and which target. Which are the parts of the inflammatory process which are damaging and which are the ones that we have there for a reason. And I want to end by inviting you to CONI, Controversy in Neurology. We have there many pro-con debates. One of them will be whether inflammation is important in Alzheimer's disease or just a byproduct. Thank you for your attention.